Section 6.1.35-T, using technology. It says one question from a survey has, how many credit cards do you currently have? The results of the survey are provided, and we're going to complete parts A through G below. So here it says click the icon to view the survey results. So the first thing we want to do is we want to be able to determine the mean number of credit cards based on the raw data. So we're going to go ahead and open this up. Here's the raw data. So we have all this information in here. And we're going to open this up in the StatCrunch. Okay, now that we've opened this up in the StatCrunch, what we're going to do is we're going to take the stat, go to Summary Stats, select Columns. Okay, and we're going to select Variable 1 because that represents the column 1. We want to find the mean. So when we select Compute, it's going to give us the mean, and so the mean is 3.08. So here we would say that the mean is 3.08 credit cards. So therefore there is our result. I'll go ahead and copy that for the first part. Okay. Next, we want to determine the standard deviation number of credit cards based on the raw data. So if we come back in here, we're going to go to Options. We're going to select Edit, and then now we're going to also include now the standard deviation by holding the Control button. So now we have the mean and the standard deviation. So let's go ahead and select Compute there. I'm going to go ahead and copy that information. Okay, and so in our example, they want us to round this to 3 decimal places. So this becomes 1.868. So therefore, we would say that the standard deviation is 1.868. Let's verify our results on this page. So there's the mean, which is 3.08, and there is the standard deviation at 1.868. Okay, now the next question they want us to do is to determine the probability distribution for the random variable x, which is the number of credit cards issued to an individual. So opening up StatCrunch, we're going to be able to then use this information to create a frequency distribution. Okay, so by doing that, we're going to go to Stats, and then we're going to go to Tables, and then we're going to select Frequency. Okay, now we're going to go ahead and use the first column here. And so what we want to do is we want to create a frequency and a relative frequency. Now what we would like to do, since it's both highlighted, we want to make sure it's stored in a table so that we can put it into our columns. So let's go ahead and select Compute. So now we can see that we have our column. This represents our number of cards. So this is going to represent, we're going to name this called X, which is the number of cards. Okay, and then we have our frequency, and then we have our relative frequency, which is the same thing as the probability of that value of X. So what that means is in our data, for the number of cards of 1, the frequency came out 13, and we have how many cards? Well, there are 100. So that means if you take 13 and divide it by 100, we get 0.13. We take 31 divided by 100 gives us 0.31. So if we take a look here on our table, okay, there is our distribution here. So we have our relative frequency, which is the probability, and let's go ahead and match that with our table here. So again, there's 1 through 10. There's our frequency, 13, 31, all the way to 2. And then there is our probability. So now let's go ahead and then answer this in our question. So we can see that matching with StatCrunch, we can see that the probability of 1 is 0.13. The probability of 2 is 0.31. The probability of 3 is 0.31. The probability of 4 is 0.1. Probability of 5 is 0.07. The probability of 6 is 0.01. The probability of 7 is 0.02. probability of 8 is 0.02, probability of 9 is 0.01, and the probability of 10 is 0.02. So therefore, we've answered our question for part C. Okay, now the next question they want us to do is they want us to draw a graph of the discrete probability distribution for the random variable x, and then we're going to describe the shape of the distribution. So we're going to go ahead and open this up in a StatCrunch. Now in order to do that, what we're going to do is we're going to go to Stat, and then we're going to go to Calculators, and we're going to go all the way down to where it says Custom. Okay, so now the values in are going to represent x, meaning the number of cards. Okay, so that's why we want to change that column heading. And then the weights in are going to be in the frequency. So let's go ahead and do that. And then we're going to select Compute. And now we're going to see our graph. And now we're going to match our graph to the ones that we can see below. So if we take a look at the first graph, we can see that this does not represent our distribution over here in part A. If we take a look at part B, it also doesn't match. Okay, if we look at part C, it also doesn't match, but if we look at D, it does. Okay, so therefore here is our distribution. Okay, now I'm going to go ahead and copy this into our data. Okay, because now the question is, they want us to determine whether this distribution, okay, if we want to describe the shape of this distribution. So if we take this graph, right, and we're going to go ahead and then trace around it, meaning that, okay, here's our graph. It's going to start up high, and then it's going to go low, and then it's going to skew all the way to the right. So we can say that the distribution is bimodal because you can see here we have these two peaks, and we also know that it's skewed right because the graph is being skewed right. And so therefore, for part D, we have our graph, and then we have the bimodal, and it's skewed right. Okay, now the next question, it says, they want us to determine the mean and the standard deviation number of credit cards from the probability distribution that's found in part C. So let's go ahead and determine the mean and the standard deviation of the probability distribution. So we're going to use StatCrunch here. So let's open up in StatCrunch. Okay, so here we have our number of cards, we have our frequency, we have a probability. What we want to do is we want to create a distribution. So remember that we want to, in order to find the mean of this distribution, we need to take the value of x and multiply it by the probability and then add them all together. So what we're going to do is we're going to highlight the column. Okay, we're going to go to Data, and then we're going to go to Compute and Expression. So we're going to build an expression, meaning that what we want to do is we're going to take this column and multiply it by this column. So I'm going to take left parenthesis, and I'm going to click on this column here, and then I'm going to close the parenthesis, and then I'm going to say multiply. Then I'm going to open up the parenthesis again, and then I want to click on the probability. Okay, and so therefore we're going to multiply these together. So we're going to take this value and multiply it by this, and then we're going to generate a column here. So let's go ahead and select OK, and then we're going to select Compute. And now what's happening is we're taking the value of x and multiplying by its probability, and therefore we're getting this information here. Okay, now in order to find the mean of this probability distribution, we need to find the sum of this column here. So we're going to go to Stat, and then we're going to go to Summary Stats and select Column. Okay, now we want to select the last column that we created, so we want to make sure that's what we're looking for. Now remember, we're finding the sum of that column is going to give us the mean. So we're going to scroll all the way down to where we find the word sum, and then select Compute. And therefore, if you look at the sum, we're going to get 3.08. Okay, now I'm going to show you what we've done here in our question. Okay, so again, taking a look at our data that we have here, right? What we've done is we have our probability, right? We took our x, we multiplied it by the probability, and then if you look here, we end up getting the mean, which is 3.08. So let's take a look at that result there. So our mean is the same as the one we got earlier. So the mean is 3.08. Okay, so what we're going to do now is, in order for it to then to create our table here, we're going to now generate a new column, which is the mean, which is mu, and that means we're going to have our mean. So let's go ahead and do that. So in here, we're going to put in the mean. So we'll just call that mu or mean, whatever we want, and then we're going to put in the value of 3.08 for each one. Okay, so that means we're going to put it in for each one of these. So therefore, there is our mean. Okay, now recall that if we want to find the standard deviation, we need to use this formula and then add it up. So what does that mean? That means that we need to get a new column. We're going to go to data, and then we're going to go ahead and compute and then put another expression in there. So we're going to build this expression by doing the following. We're going to have left parenthesis, and then we're going to take the value of x, which is this column here, which is the x number of cards, right? And then we're going to subtract, so we're going to put minus, and then we're going to subtract the mean, which is the column that represents mu. And then we're going to put the right parenthesis, and then if you notice, we need to square that. So we're going to use the up arrow key, and then use the 2 because we're going to square that once it computes that number. Then we're going to multiply it by the probability. So we're going to take multiplication, and then we're going to multiply it by the column that represents the probability. So left parenthesis, there's the probability column, and then right parenthesis. And now it's going to compute this information here in this column. So let's go ahead and select OK, and then select compute. Okay, now I'm going to open up this part here so you can see if these numbers match. And so therefore, you can see that these numbers match what we get here. Okay, now the next thing that we want to do is we want to find the sum of this column. So that means we're going to have to add up all these numbers in this column. So in order to do that, we're going to come back up here. We're going to go Stat, Summary Stats, and select Column. And now we're going to pick the last one that we made, which is the last column here. And then we're going to go again. We're going to go back over here and select Sum, and then select Compute. Now the sum that we get is 3.4536. So coming down here, you should see that we get 3.4536. Okay, now once we get that sum, what we're going to do is now we're going to plug it into the formula to find the standard deviation. So that means we're going to take the following. We're going to take the square root of 3.4536, which we could do in our calculator here. So the square root of 3.4536, and then there is our value. We get 1.8583864. Rounding to 3 decimal places gives us approximately 1.858. And so therefore, we get the mean, which was 3.08, and we get the standard deviation to be 1.858. And so therefore, we can go ahead and then write our mean, which is 3.08, and the standard deviation of the probability distribution is 1.858. Okay? So now the next question is to determine the probability of randomly selecting an individual whose number of credit cards is more than 2 standard deviations from the mean. And then we need to determine, is this result unusual? Okay, so let's go to this question here. So the first thing we need to do is we need to determine the number that is 2 standard deviations below and above the mean, where we're using the mean to be 3.08 and the standard deviation that we found in the previous step as 1.858. So what we're going to do is the following. We're going to use this formula, right? So we have mu minus 2 times the standard deviation. So we know that mu represents 3.08 minus 2 times the standard deviation, which gives us the value of negative 0.636. And then what we got to do is we got to find mu plus 2 times the standard deviation. So that means we're going to take 3.08 plus 2 times the standard deviation, which gives us the following numbers of 6.79. So that means that we need to find the values it says more than 2 standard deviations from the mean. Well, that means more than is going to be more than 6.7 using the x values. So anything that's more than that is the value of x, and anything that's more than 6.7 are the values of x where we have 7, 8, 9, and then 10. So for the values of those values, now we need to look at the probability of those. So what is the probability of 7? Well, it's 0.02. What is the probability of 8? 0.02. What's the probability of 9? 0.01. And what's the probability of 10? 0.02. So now we want to find the sum of the corresponding probabilities for each of these values of x. So what we're doing is we're finding the probability of 7 or 8 or 9 or 10, which is equal to the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10. Well, remember that we know what those probabilities are. Okay, what those probabilities are, what we just defined here, 0.02 plus 0.02 plus 0.01 plus 0.02, and therefore when we add them together, we get 0.07. So the probability is 0.07. So going back to our question, we can see that the next answer for the probability is 0.07. Now we need to determine if this result is unusual. Well, remember that in order to determine if it's unusual or not, we need to compare it to 0.05. Now, we know that 0.07, okay, if we take a look at 0.07, we know that this value is greater than 0.05. Therefore, we would say the result is not unusual because the probability is greater than 0.05. Okay, so answering our question, we would then say the following. We would say that this result is not unusual because the probability is greater than 0.05. Now the next question is, determine the probability of randomly selecting 2 individuals that are issued exactly 2 credit cards. And then the hint is, are the events independent? And then we're going to interpret this result. So, okay, again, we want to find the following. We're looking for selecting 2 individuals who are issued exactly 2 credit cards. And so the hint here is, are the events independent? So the probability that 2 events E and F both occur is the probability of E and F, which means you take the probability of event E times the probability of event F provided that E has already occurred. So if the 2 events E and F are independent, then the multiplication rule for independent events can be used as shown here below. Now the events is selecting a person from the sample and then selecting a second person from the sample are not independent because once one person has been selected, the number of possible choices for the second person has been reduced. So recall that the 2 individuals who are issued exactly 2 credit cards. Well, here is the value of exactly 2. So what is the frequency of that? Well, the frequency is 31. Okay, so that means that the frequency of exactly 2 is 31 out of how many that are in our sample size? Well, the population size is 100. So that means that this would be the probability of E is going to be 31 over 100. Okay, now once one person with 2 credit cards has been selected from the sample, then there are 31 minus 1, which is 30 ways a second person with 2 credit cards can be selected from the sample. So therefore, we would then say that 30 is now going to be the next part of the probability for the numerator. Now, once one person with 2 credit cards has been selected from the sample, then there are 100 minus 1, which is equal to 99 ways a second person can be selected from the sample. So therefore, the probability of F is going to be 30 divided by 99. So what we're going to do now is the following. We're going to find the probability of E and F. Well, we know the probability of E is 31 over 100 times the probability of F, which is 30 over 99. So there are our values. We have 31 and there's 30, and that's over 100 and that's over 99. So when we multiply them together on our calculator, okay, so we have parentheses 31 divided by 100, and then times 30 divided by 99, and then that gives us the following. It gives us 0.0939394. And therefore, we're going to round that to 3 decimal places, which gives us 0.094. So that means the probability now is 0.094. Okay, now that we have the probability, which we can say here, okay, the probability is 0.094, right? And so now we want to then rewrite this in terms of 2 decimals so that we can interpret the result. So 0.09 is the same thing as 9 over 100. And so in order to interpret this result, we would say the following. We would say that if 2 individuals randomly selected surveyed 100 different times, the surveyors would expect about 9 of the surveys to result in 2 people with exactly 2 credit cards. So therefore, our result would then be the following. There's the probability of 0.094, and if 2 individuals are randomly selected, surveyed 100 different times, we'd say the surveyors would expect about 9 of the surveys to result in 2 people with exactly 2 credit cards.